So it's similar to the stuff that you did on your homework. And then after we go over this, maybe there's too many here, I have a replacement quiz. So I know some of you did get 100%. When I say some, I mean like 2 or 3. But most of you didn't do so well on this last quiz. So I have a replacement quiz called Quiz 17B, where you'll be able to all get hundreds after we talk. So let's just go over this. I'll do a few of them, and then you'll do a few of them. And so I can explain what I'm hoping you do, especially because I want to avoid mistakes when we get to our exam, because that's the worst, is when everyone does the wrong thing on an exam. It's okay on a quiz, because it's like, oh, it's a throwaway thing. But on an exam, that's the worst, is having to give you bad grades on your exams. So let's fix some of this. So, does everyone have this piece of paper that I handed out? It's got like 2 columns. Everyone except for Easton, okay. Well, so let's take a look at this. Number 1. So in each one of these are basically, we're just going through the first few steps of a hypothesis test. So this is why I'm so concerned, is because, as I mentioned last time, from here until the end of the class, until May, or I guess April 30th, or whatever the last day of classes are, we're going to be doing this every single day. Every time we hit a hypothesis test, we're going to be talking about the claim, the opposite, blah, 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 all of these things. So if you don't have this sort of foundation, it's going to be, you're going to be sunk. So let's take a look at this, and let me give you a few pointers. First off, I don't want to see words if I can avoid it. I did not go into English or literature or anything like that, and things that require writing. And it was kind of sad to me when I realized that statistics, you do have to write some sentences, but let's be, judicious about the sentences we write. And so we'll save those for the end when we're trying to communicate our conclusion. So that's the only sentence I want out of you when you're writing a hypothesis test. The rest of it, just numbers and symbols. So let's take a look at this one. We want a claim, but we want to do it in symbols. And so, researchers, what in the world? Yeah, you fix that if you want to. So the first thing you want to do is you ask yourself, is this about an average or is it about a proportion? Averages or proportions? It looks to me like it's talking about a mean, and we're looking for a claim. We want to show that. I think that this would be the claim right here, that these researchers or researchers think that it's not accurate and want to show that the mean age is not equal to 40. So actually write that down in math. So mu is not equal to 40. So a couple of things that really, like, I hate to say that they irritate me, but it does, is when someone does this, like if you do this, come on, can't you write that symbol? We can all write that symbol. Just put a U and put 2 tails on either side of the U. So don't give me an X. Don't put X there. Don't put a P there. It is a mean, and it should have a mu for mean. Now, once you've got that, that's the claim, is not 40. Notice mu is not equal to 40. Now, the rest of this, hopefully we can do without referring back to the words up above. The opposite is that the mean is equal to 40. How easy is that? You just do the opposite. By the way, here's a quick hint, is you have this and this are opposites. So let's do that. This and this are opposites, and then this and this are opposites. So I know it's hard, all of those symbols, but we'll work through, hopefully, by the time we get done with this 7 questions, you'll have this in your head. What do you think, Hayden? What? That is correct. I'm sorry. Okay, when we get to the null and alternative hypotheses, that's where you worry about the equal sign. Don't worry about where the equal sign is when you're doing the claim and the you just want 2 things that are opposite one another here. So Anna, what do you think?
So why is the researchers that are trying to prove that's not accurate the claim and not
I see. Okay, so there are 2 claims. Okay, Well, I guess the secret is that if you had written this down, I would have been happy. As long as you have two opposing claims. So yeah, I guess I was so focused on the researchers or whatever I said there that I didn't even read the first sentence because I saw that misspelling and it bothered me. So yeah, you can go either way as long as you have two opposing statements that are accurate for the problem that is, so that's all I really care about. Okay, now that we got that, now let's go to what Hayden was referring to, and that is that we're going to be finding the null and alternative hypotheses. And so here, the null hypothesis will be the one with the equal sign. It doesn't matter, this part, so this, you can switch these up. It really doesn't matter to me, because technically, you're always going to have two opposing viewpoints, and they have to be complete opposites of one another. When you get down here, though, we want to sort them into categories. The one with the equal sign is the no difference, the null hypothesis, no difference. And so that's the one that's going to be for the, the null hypothesis. So mu is equal to 40, and then over here, mu is not equal to 40 is this one. Then once you got this, hopefully this part is easy, it's two-tailed because you're looking both directions. That's probably not a big issue, but I've got it there because it's on every single quiz and it's on every single test problem. Okay, any other questions about this one? We're going to be going somewhat quickly through this, just to warn you. So I'm going to do, let's see, is this another one? No, I don't want to do number 2. I'm going to let you do that in a minute. Okay, I like number 3. Number 3, let's talk about Charlotte, just so that we can find out what's going on with her. So Charlotte is a high school student who read in an article that stated that only 46% of teens have a driver's license. And she claims that the percentage is greater, because who doesn't have a driver's license? At least for the students at her school. So at her school, she thinks that there are more people with licenses. So Charlotte randomly selects 126 students and finds that 67 of those surveyed had a driver's license. So what is the claim? Well, let's see. She thinks, where is it? She claims, there it is. Now notice that this is talking about percentages or proportions. And so the claim is going to be about P, proportion, percentage, I don't care how you think of it, as long as you use that letter. So don't use X, don't use mu here. I know you're proud of your ability to draw that symbol, but don't use it down here. So P for proportion, mu for mean. Okay, so claim P. P is, she thinks it's greater than 0.46 or 46%. I don't care if you write it as 46%, doesn't bother me. And then the opposite of the claim is that P is less than or equal to, 0.46 or 46%. Once again, I don't care. So let's just pause for a minute, make sure that the symbols make sense. And here again, although this one you might have trouble arguing that you could switch these two, but if you switched them, I wouldn't care so much. This stuff, letters A and B, are really just there to help you to sort out what C is. C is the important one. Oh, no, not C. D, sorry, we'll get to C in a sec. D is the important one. So A and B are just kind of in service of figuring out the null and alternative hypotheses. Jesus, what do you think? Ah, interesting. So you're saying this, P equals like this. Yes. Oh, yeah. Okay. Well, hold on a sec. Let's see. So the homework, they didn't ask you these two questions. Yeah. So the homework asked you just this question down here, letter D. These are to get you, they're stepping stones to help you. They're supposed to be helpful to get you this. So I think that if this were an exam, and if you wrote, if there, I'll just move this over so you can't see it. If I was looking at your exam and I saw this, especially if it was you, Jesus, I would say, I'm happy. So yeah, I mean, technically, if I was really a stickler for the actual accurate truth, that's not correct because it is not the opposite. But I'm happy because really, like I said, A and B here, they are only there in order to get you to get a good answer for D. That's what I really care about is your answer for D. And so honestly, what I'm looking at when I'm looking at all your exams, when I get to this problem, I look at D first. I'm like, oh, do they have it? And if they have it, I just glance up here and I'm like, okay, they have something up here. I guess they're good. But it's when you don't have this correct that I'm like, wait a minute, what's going on up here? Why did you get it wrong? Yeah, so down here for sure, I would let you, I don't care if you write in equals, it's fine. Wow, that was a long answer for a short question. Sorry about that. Anything else before we get on to part C? Okay, so part C, I threw it on there because it was part of your homework, I think. I think the homework referred to this, so I need to mention this. You probably read about it because you're like, what is this? Okay, so when you're doing the hypothesis, or not, yeah, hypothesis test for proportions, you want to make sure that your data is, that you have enough data. So maybe I could say it that way. So you want to make sure you have enough data. And the way you know if you have enough data is you take your sample size and multiply it by this proportion. So 126 times 46%. What is 46% of 126? And you ask yourself, is that bigger than 5? You want to make sure that you don't end up with, because if your sample size is too small, then it can mess up some of the, the data. So for example, here, if this were the claim, then you would want at least more than 10. If you had only 10 people in your sample, 46% of 10 is less than 5. It's too small of a sample size. That's all this conditions of the hypothesis test really refers to. What do you think, Elizabeth? It is a number that mathematicians have come up with that we don't want to go into all the mathematics behind it, but what it does is it ensures that nothing weird happens in terms of the probabilities when we get down to the end of the hypothesis test. So if you have essentially what happens here, I guess, yeah, since you asked, too late now. When you have a small number like 5, so if the number is bigger than 5, usually the binomial distribution looks something like this. Looks like a normal curve. But if that number is low, like 5, then what happens is you end up with something that looks like that. It doesn't look normal. And so because it doesn't look normal, the tools that we end up using don't work as well. So that's it. So it's just sort of a cutoff where so mathematicians have come up with this. And it's kind of a sliding scale. You could have cut it off at 6 or 3, 4. No, 4 would be too small probably. But yeah, it ends up, when that number is too small, it ends up skewing the data. Okay, so this one, yes. Okay, whatever. I don't know, what was it on the, I guess on your homework, it would be like a sentence. Yes, they had like sentences you had to choose, but you could just say yes. Okay, null and alternative hypotheses. P is less than or equal to 0.46. So that's the null hypothesis. The alternative is that P is greater than 0.46. This thing is a right-tailed test. And now finally, compute P hat. What in the world is P hat? Well, P hat is the proportion from the sample. And so that's going to equal 67 over 126, whatever that is. You can do it on your calculator if you want to, but I'm just going to leave it like that because I'm worried about getting through this so we can get on to the next thing. So any other questions about this one before you try a couple of them? All right, good. So go back up to number 2 and then also do number 4. So 2 and 4, those are your job to do. And we'll see how we do as a group in just a minute. So I'll give you a couple minutes, work with a friend, and let me know if you want me to come and impose myself on you. Looks like a few of you are done, a few of you are still working. So let's go ahead and see how we're doing with number 2. Joshua, what do you get for the claim? So mu is greater than 20. Very nice. So yeah, we can see claim greater than 20, the average, mean greater than 20. There it is. Very good. Dante, do you know the opposite of the claim?
The opposite would be mean less than or equal to.
Very nice. Mean is less than or equal to 20. Okay, Jesus, you can tell me what the null and alternative hypotheses are, and you can call them however you like.
The null is equal to 20, and the alternative is n is bigger than 20.
Okay, very nice. So Jesus chooses to leave off the less than part. That's totally fine. That's fine with me. So very nice. By the way, I just want to point something out about this, is that for this stuff, you need all of these symbols. If you leave off any of this, it's wrong. For example, if you leave off this, you see what I got rid of, the mu? It's wrong. It's just what is equal to 20? The null hypothesis is equal to 20? No. The null hypothesis is the statement that the mean is equal to 20. So don't leave off any of the symbols, and don't change this to a Q or an X or whatever. Hayden, what do you want to tell me about? Good point. We'll get back to that. Okay, so let's do the next 2, and then we can talk about that 25 in just a sec. So Sarah, is this left, right, or two-tailed? It is right-tailed. Very good, because you're looking at this alternative pointing that direction, right-tailed. And then alpha. What is alpha? Well, alpha is the significance level. And so I wanted to make sure that you started seeing words like this, significance level, referring to alpha. So it might be embedded in the problem like that. Statisticians oftentimes will refer to the significance of their findings. So 0.05 is alpha. Now, what about this 25? Well, the 25 is the sample mean. So if I were to go through and label these things, this thing here is n, that thing there is x bar, this here is the standard deviation for the sample. I'll use a little s there. That number is alpha, and this number is mu. So when we get to doing this stuff, maybe even later today if we get to it, we're going to want to identify each of the numbers in the problem, in the stem of the problem. So that x bar, what are we going to do with it? Well, we're going to type it into Excel, and we're going to use it as a comparison to see whether or not by chance we just happen to have a larger class sizes than the true average. So it just could be that by chance I have randomly selected a bunch of classes that are a little bit larger than average, and just, by chance that could happen. And we want to know what is the probability, and that's what Excel is going to do for us. Okay, so that's number 2. Let's go down to number 4, see how we did down here. So who do we have here? So Elizabeth, what is the claim here?
I didn't do this one yet.
Okay.
I'm sorry, I stopped at 2.
You got excited about 2, and you're like, I'm done. Okay, well here, let's read this over with me. Just that first sentence. The politician recently made the claim that 47% of taxpayers from a certain region don't pay income taxes. Okay, so here's our claim. It has this number. So which symbol do you want to use? Okay, we have an equal sign. I guess I was thinking of the symbol that goes before that equal sign. The little p, or I'm going to use a big P. But yeah, either way is fine, I guess. I'll take either P. So P is equal, that's what the politician is claiming, 47%. Now you have Michaela, a journalist from an online media company, is testing this politician's claim for an op-ed. Okay, so nothing wrong with that, but we do need to know the opposite of that claim. So Alec has the opposite, don't you? What's the opposite of P is equal to 47%? Yeah, P is not equal to. Very nice. All right. Are all conditions, so here, I only have it there, like I said, because it was in your homework somewhere, and I thought, well, I better stick it here. But you can just take that 47%, multiply it by your sample size. Your sample size is plenty big enough for this particular hypothesis test. 159 times 47% is like 75. So you're good. Yes, it's met. You just check that one off. I guess I've glossed over this. The conditions are that both 47% of the sample size and the opposite of 47% of the sample size, both of those should be bigger than 5. Sorry, I guess most of our examples are going to be fine in terms of that. But let's go on. Null and alternative hypotheses. We can do this. Will knows. Will, what's the null hypothesis? Very good. P is equal to 47%. So, like I said, the reason I do A and B is just stepping stones. You're going to pick from those which one has the equals in it. He got it. Good job. And then P, whoops, let's change back to here. The alternative hypothesis is the other one. There you go. And so there they are. And here, I just want to emphasize again that you need all of these symbols. And I know it's a pain to have to write down all these symbols, but it's better than writing a sentence, is it not? So don't leave out anything. You need all of these. So if you get rid of this, for example, that's not correct. This is the most common wrong way to write this. Another wrong way to write it is to put the wrong symbol in there and call it the mean instead of the proportion. So that's what it should look like. Also label these. If you omit this stuff, that's not quite right. I guess some of you had drawn arrows, null and alternative, but you might as well just write. I mean, what's the big deal? Just write that. Okay, almost done with this, and then we'll see where we are. Carson, is this left, right, or two-tailed? It is two-tailed, very nice. And then we need to compute p hat for this particular data set. I'm sure you've done this already, haven't you, Ethan? What do you got? All right, 73 divided by 159, whatever that is, it's about 50%, a little bit under. So very good. All right, so do we need to do any more of these before we do the quiz? Let's see, is any of this good? Maybe we'll do one more. I know there's a lot of them here. How about this? You do one more. Which one? You pick, and I will do them all really quickly. So I'll freeze. You pick which one you like the best. If you like Austin or the survey or the last one, the airline company. And I'll just put down the answers. And then if you really want to look at those answers, you'll be able to see them on the video. I'll show you them all now, but you might not have time to write them all down. So give me a minute here. You take your time, pick one, and that way we can at least make sure that you're good. Wow, you guys are quick. I'm almost done. I'm writing more though. All right, finally, all done. Okay, so let's go back to the beginning. You can compare your answers with mine, and we can talk if you have complaints. So let me just blow through this really quick. And once again, and so notice I actually wrote out what it means for the conditions for the hypothesis test to be met, is that you're checking that 56% of 224 is bigger than 5 and 44, so the opposite, 44% is greater than 5, which is, it's true. The only one where there was ever a question actually in my mind was the last one. We'll get to that in a sec. And so then I've got this all sorted out. Hopefully that's right. You got a complaint? What's going on? Oh yeah, yeah. You just say yes. I just wanted to have at least a record of that's what you're checking. Yeah, yeah, yeah. You can just say yes. That's fine. Any other? Yes, Hayden. What? To get 44%, I took 56% and subtracted from 100%. Yeah, it's the opposite of 56% or the balance, yeah. All right, so let's do the next one. If that's the one you chose to do, here it is. If it isn't, you can always get this from the video and later if you want to watch it. Just fast forward, pause. It'll give me one more view. It'll make me feel better when I look at my analytics. And yeah, it used to be that I would look at the analytics and it's like 2 views. And it's like, oh, that was great. But now, for some reason, in calculus, I don't know why it is, but in calculus, I'm getting like more views than I have students. So I don't know if I'm becoming an influencer. Yeah, maybe. Of course, yeah, I mean, it's only 40 views though, so 40, okay. Anyway, getting back to this, this look good? Yeah, what's wrong? Where? Oh, letter F? Oh, that's okay. This is alpha. Sorry, it's a Greek letter alpha. Yeah, that's the Greek letter alpha. Sorry about that. Yeah, the little fish looking thing, or maybe it looks like a little guppy. I don't know. Okay, yeah, that's alpha. I just typed it. That's what the font looks like, I guess. But the way I write it is like this, like a fish. So there it is. It's alpha. So excellent. Thank you for pointing that out. Next, let's do the last one here. So here it is. If you're curious, yeah, this is the only one where I thought, ooh, it might be because 94% means that the opposite of 94% is 6%. 6% is a really small number. That's when you should be worried. But my sample size is plenty big enough to, it's way bigger. So 6% of 315 is like 19, way bigger than 5. So I'm good. So look good. So you're gonna do it great on the quiz now. So this is the replacement quiz. So hopefully this won't take too long. So even if you got 100 on the first one, well, that means you'll probably get 100 on the second one. So here you are. Enjoy. Here you go. Sorry. Here's 2. I know August wants 1, so let me give her 1 too. There. Whoops. 1, 2. There's 3, I think. If not, I'll give you another one. Is that right? Yeah, good. Do you need one more? Sure. There's only 2 there. I'll get you another 2. There's too many. There's 1. There's 2. 1, 2. Here. I know you're last, but you're okay. You're probably going to be done first. Oh, is that too bright? We can close that. Yeah? Okay. Let's see, I have the technology. Better? But now, Ethan, are you okay? We could, okay. Well, we can always adjust. You can get up and adjust it yourself if you need to. Did everyone get a quiz? All right, I'll go show you my quiz for those who are watching from home. Here it is. Freeze, okay. Oops. Where's my calculator? Okay, I see there's a typo. Okay, sorry, I'll put it up on the screen. If it bothers you, there it is. You probably it's probably autocorrect or something. I'll blame it on autocorrect. Great. Looks like some of you are done. I'll come and get what you have. This good for me? All right. Set. I'll come back around. Don't worry. If you're still working, you can do it. Well, yeah, try to speed up though. You're okay. All right, you're all set. Oh yeah, I don't want to rush you. Well, I don't want to rush most of you. Some of you I do want to rush. Nice. Okay, very good. You got it? Okay, good. Excellent. You're checking the work. Oh, wait. Oh, that's an extra one. I was wondering why you had segregated it. It's fine. You're all set? Good? Both of you? All right, good job. Well done. What else? You're still working? Oh, you're just meditating on it. I'll come back for it. Don't worry. What? Today? Oh, I shouldn't have worn black then. All right. Maybe I'll wear my seersucker tomorrow. All right. All right. You're all set? Excellent. How about, is that one for me? It's not an old one? All right. Yeah, it's a new one. Good. Anyone else? Anyone else? No. All right. You got it. You can do it. Yes. I knew you could do it. Well done. Good job. Good job. All right, anyone else? Do I have all of them? All right, I'm stapling. Okay, so this first one, when I read this over, I thought, oh, it's poorly worded. And then I thought, I can blame it on Newton because I had copied most of these. To be honest, I copied them from Newton. I was just like, oh, that looks good. I'll just use that one as an example. This one, though, I can't claim that. I wrote this probably a couple years back. It just seems a little wonky the way that it's written. So anyway, here's the statement. Let's see, yeah, just poorly written, I think. But Jordan it's English. English is not my forte. Jordan is the provost of a university. He's looking into whether the 6-year graduation rate for freshmen in the class of 2016 at his university has increased. So we want to know, has it increased? Has it gotten bigger than 59%, which is, yeah, that's terrible. That was, I'm trying to say, it was the graduation rate for the class of 2011. So he surveys a random sample of 82 students who were freshmen in the class of 2016 and discovered that 51 of those students graduated within 6 years. This is the sort of thing that universities do. We care about this stuff because we care whether we're doing a good job. So as you can see, I've highlighted the important statement here. Proportion is bigger, 59%. And so the opposite is that it's less than or equal to. And then I actually did the math, but you could have just said, yeah, sure. And then there's my stuff. This thing is right-tailed, and I computed my proportion. So then over here, this one was a little bit better in terms of the wording, other than the fact that I had the typo, because it's just one sentence. So mu is greater than 5,500, more than, there it is, more than 5,500. And then mu is less than or equal to. I'm looking for the symbols. Can you actually write it? And if you're having trouble, once again, it's so easy. You make a U, and then you put a little tail on either side. That's all you got to do. So, and this symbol seems to cause problems as well. That one, you put a line, and then put a little thing there. Okay, so getting back to this, there it is, right-tailed. Good job. Okay, what are we doing today? Okay, so today we're going to get set up. I don't know that we're going to have time to do it all. Let's see, give me a sec. We're going to be using Excel. So I'm going to get you started on this little project that you're going to finish for me on Friday. So let me find my stuff. Pardon me. Come on. Oh, I'm looking for my PowerPoint, and it's not in the calculus folder, of course. Sorry. Yeah, I know. So like, where is it? Okay, just a sec. Hypothesis. Almost there. Not there. Come on. I mean, I could just wing it, but I'd rather not. Sec. Hi. I got so excited about this stuff here that I wasn't as prepared with this. Come on. There it is. Okay, so in Excel, what we're going to be doing is we're going to be making a hypothesis test spreadsheet similar to the hypothesis test or the confidence interval gold spreadsheet. So it's sort of similar feel. So that's what we're going to be doing. We're going to just blow through this super quick here, this hypothesis test steps. We have the claim, the opposite of the claim. You're already professionals in this. You have the null and alternative hypotheses. You have alpha, which is always going to be given to you. Given, you'll have a problem, it'll be given to you. Then we have the determine which distribution you'll use. So this is the thing that's going to differ. We're going to do the hypothesis test for the means today, or at least with as much of it as we can in the next 10 minutes, because I need to give you instructions for what you're going to do on Friday for me. And then you'll do the rest of it on your own, but don't worry, there are videos. Then you're going to compute do that on Excel there, compute the test statistic and p-value. Then you'll make a decision and summarize your results in a complete sentence. Hopefully we'll get to this today. If not, it's on the video, so you'll be okay. Hopefully. So that's the plan. And it's number 5 and 6 that you do with Excel. Well, actually 5 you do on your own because you got to figure it out. But then 6 you do in Excel. So give me a sec here. Where is this here? There it is. So I can write on it. So there it is. So this is the step that is going to be the tricky one, is to figure out which distribution you use. But fortunately for us, we're going to do this in Excel. And for means, we'll use the t-distribution. Proportions, it's the normal distribution, just like with the confidence interval stuff. Then here's step 6, and this is the one that's a little bit scary, but don't fret. I'm going to work with you with this. So in step 6 for means, we're going to compute the mean from the sample and the standard deviation from the sample, and we're going to have the sample size. So we're going to need those 3 things, very similar to when we did confidence intervals. Then we're going to compute what's called the test statistic, and you'll notice that this test statistic looks familiar. Well, maybe it doesn't to you, but it does to me, because a lot of statistics follow this same pattern, the z-score pattern. You remember the z-score? You have your observation minus the mean over the standard deviation. You remember doing this? We figured out like that if you're above average, you'll have a positive z-score for your height. If you're below average, a little shorter than average, you'll have a negative z-score for your height, that sort of thing. This is basically the same idea. It's just you have your observation is your sample mean. The thing that instead of a mean, you have the null hypothesis, and instead of a standard deviation, you have this thing that looks like a, it's called the standard error for the mean, but it's like a standard deviation. So that's the idea there. And then we're going to be computing the p-value using Excel. We have several different ways of doing this. And so let's just cut over here so I can have this up here at the same time as I have my Excel stuff. So give me a sec, I'll bring this over. So you should have a brand new, here, how am I going to do this? Just a sec. I need to get, hold on. Let's see, I will do this. Okay, this will do. Okay, let's see, can I stick this up here? Sure. Okay, give me a sec. There, and then I want this over there. There we go. That's what I wanted to do. Okay, so let's get this up here and this up here. Now we can see both. Sort of. I guess I can crank this over just a bit. There. Good enough. Okay, and we'll zoom way in to this. So let's go ahead and do all of, oh wait, that's step 6 for proportions. Man, where's my step 6 with, oh, it's all there. Why is it, should be crunched over. I thought I had made it, let me see if I can fix this. Give me a sec. Here it is. Sorry, the PowerPoint changed for some reason. Let's just push this way over there. That's better. And let's get rid of that ink. Clear. Okay, much better. Sorry, I thought that it was 2 separate. There, that's much better. So now we can see the steps, and we can see the Excel. So we're going to basically just go through these steps to compute the p-value. So what I want to do is go up to the very top left corner of your spreadsheet, and we're going to start off just labeling these things. So we're going to have the mean of our sample, we're going to have the standard deviation of our sample, and we're going to have the sample size. So n, which is the sample size. I'll do that, whatever. Okay, so you can label them however you want, and honestly, I don't know how I did it in the other video, the one that I'm going to refer you to, but if we can get through this particular sheet, then you won't have to watch at least half of the stuff that I've got ready for you for Friday. So we've got that. It says that we're going to compute the test statistics, so we'll just call that T. Well, I'll label it test stat. There we go. We're going to compute the p-value, but notice that the p-value has 3 different versions. So here's how I'm going to do this. Value, and then below this I have left-tailed right-tailed, and then two-tailed. So something like that. I guess it's bothersome to me that I don't have the ED. I'm going to have to put it on there. Sorry about that. There, that look better? Okay, so let's go ahead and find a problem where we can do this. So is this one? No, that one's not one either. Okay, so we need an example. Do we have one from here? Mean. Which one was it? The 25. That's it. Number 2. Number 2 on this sheet. So that's what we'll use as our example. So we'll actually use the 25 here. So notice that it says on number 2, it says a simple random sample of 40 classes. Okay, so N is 40 for this one. Resulted in a mean of 25 and a standard deviation of 6.5. So when you use this, you know what we should do before we go any further? I'm going to save this because I'm scared of losing it. So save it as, and I'm going to stick it right here where I know where I'm going to find it in my statistics folder. And I'm going to call it confidence interval gold. Oh yeah, it's hypothesis test. Sorry, I've got confidence intervals on my brain. Thank you. You saved me from, okay, thank you. Hypothesis test gold. Okay, so there it is. Here, you want to see it bigger? Let's see, does this get pixelated? Oh, it does. That's so bad. Why is it so ugly? I mean, you would think that the zoom feature would actually make it look good, but it doesn't. Okay, well, anyway, there it is. So save it somewhere that you know where it is because you're going to want to be able to use it later on. Also, I'm going to do as I did before. Let's highlight these things and make sure that they're those things you can mess with, but everything down here we don't want to mess with. So we'll like turn those red and maybe highlight them yellow. Like don't mess with this stuff down here after you get the formula working, I should say. So once the formula is working, don't mess with it. Ooh, I left off something, didn't I? Okay, here, what you're going to need to do is shove a new, there. So you go over to the left and you can right click. I don't know about those, or you could just move everything down, but I need 2 more. I forgot about these 2. Okay, so the 2 things that I left off was the null hypothesis, H0, null hypothesis, and then the other one is the alpha level, so alpha. So I need both of those, and the reason being that I'm going to need the alpha level down here, I'm going to need the null hypothesis up here, so all of this stuff I'm going to need. So null hypothesis, what does it say for problem 2? It says that the null hypothesis, because you did that one earlier, or we did it together, null hypothesis is that the mean is equal to 20, because that's what it says. Is this claim that the sample is from a population with mean greater than 20? So 20 is the null hypothesis. Alpha is 0.05. Now that I think of it, I don't really need alpha, but doesn't matter. Okay, so now here's my job, is I'm going to type this thing in. That is going to be here. So I'll do it slowly, but once we get it typed in, you don't want to mess with it, so that's why I turned it red. So this is going to equal, and open parenthesis, we're going to need parentheses all over the place here. So equals, open parenthesis, do your mean of your sample, so that's B1, minus the null hypothesis, and then close parenthesis. I'm not done. I just want to point out that when you do this, you got to put the numerator, put parentheses around the whole numerator. Otherwise, you'll get the wrong answer. And then divide by, and then I'm going to put another set of parentheses. And that S sub x is the standard deviation for the sample. And of course, n is the sample size. And you should recognize that. That looks like the conversion that you did for the central limit theorem, and it is. That's exactly where that came from. So standard deviation divided by the square root, and you use squirt for square root of the sample size. So let me just move my thing over so that you can see it a little bit better. There. And then I'm going to close out one more parenthesis. There we go. So there you can count the parentheses. Make sure yours looks like this. I'm just going to hit enter briefly, and then I'll just so that I can tell you what number I get. So I got 4.86, and then there's the formula again. Oh, why did it go down like that? Try again. There we go. So far, so good. 4.86. Still typing. Take your time. Oh, it's almost time to go. Crud. Yeah, I need to, after we type this, I need to give you some instructions. So, okay, so sadly we aren't going to get the p-values, but they aren't difficult. You'll get those from the video. So here's what we're going to do. So save this, save it again. Now, what you should be doing for Friday is, here we are. When you go to our Moodle page, and I'll remind you of this, I'll send you, whoops, where'd it go? Oh no, where did my thing go? Oh, why is it so little over here? So weird. Okay, there it is. Okay, so I'll remind you of this on in an email tomorrow, but what you're going to do is, since I already had the Snowpocalypse tab, I thought, well, I'll just throw this under there. So if you go to the Snowpocalypse tab, you'll find, here we are, a bunch of stuff. But Friday, March 21st, there's a new thing there. So you click on that, and here's the instructions of what you're going to do. Do Baby Project 1 if you haven't done it already. By the way, when you go to Baby Project 1, make sure you look. There is a YouTube playlist with me doing Baby Project 1. So if you're not sure what to do, you can just follow the instructions on the YouTube playlist. They're all like 2 to 3 minute videos. They're super short, quick. These are not short and quick though, so let me explain briefly. This is me doing this lesson last semester, and so when you click on these, it says start at 22 minutes. This is, hopefully the sound isn't up. Yeah, it's not up. But see, notice that this is exactly where we were earlier today, and if you fast forward, you'll find, oh look, it's like the exact same thing that we just did. Blab, 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 blah, blah, blah. And so you could just scroll ahead and get, yeah, see, look, it looks almost the same, but this was last semester. So I'm there blabbing away. And so, yeah, you want to get to this point where you're doing these p-values. So p-value left-tailed, right-tailed, and two-tailed are the three that we didn't get to today. So that's that video. And then the other video, where is my little pointer? So if we go back to the instructions, then this one is to get you to do the hypothesis test for, so it looks similar, doesn't it? The hypothesis test for the proportions. So let's see, this one, no, that's the old one. Okay, just a minute, blab, blah, blah. Here we are. Okay, so notice that here it is, and you can zoom in, you can fast forward, you don't have to watch the whole thing. Look how slowly it's going. You know what? I'm sick of this. Let's go to settings. Can't we speed this up? Playback speed. Let's crank it all the way up to 2 times. There, that's much better. It's still slow. What in the world? Well, anyway, I guess I have it muted. I probably don't want to hear myself. So, one other thing before you go is with these videos, that I did that before I had the joy of a wireless microphone. And so I noticed when I watched this yesterday, when I set this up, that when I walk away from the computer, I get quiet. So sorry about that. Now I have the wireless mic, so it's all good. So that's the deal. Hopefully this helps you out. And so that's what you're supposed to do Friday. So Friday, you don't have to get up early, or you could set your alarm and get up and just do it in your room. You can do it whenever you want on Friday. But this will help you with the homework and with the projects. So that should do it. I'm going to stop my recording. I'm going to stop this